All right, in this video, we're going to show you how to wire up a all-in-one hybrid inverter. So these inverters are getting really easy to do yourself, and you just got to hook in some of the wires, and we're going to show you how to hook those in, what they all mean, and how to get it up and running, and how to read out the display. And so what you're going to need to do this is a little flathead screwdriver, depending on the terminals in your inverter. These ones are small flathead screwdrivers, so you're going to need that. You're going to need just some other tools, random tools. You'll have to look at that on your inverter to see what types of tools you're going to need. You're going to need wire, and a real easy way to wire these in is get a decent gauged adapter plug. It's pretty much all this was a 1 to 3 adapter plug, and so we cut it in half, and we used this half on the output side of the AC, and we're going to use this half on the input side. And so these hybrid inverters, they have an AC in, which is where you would take a generator and you would fire up the generator, and the AC, the power would go in, and it would be used to charge the batteries with a generator or with the grid. And then you have the AC output. This would go to your all your devices that you need to run, or your RV, or whatever it is. And then you have the solar lines, and all of that can be seen on the instruction manual that it will likely come with it to show you what everything is and how to hook it all up. And you'll also likely be able to see it labeled on here. So we're going to go ahead, and as you can see here, we've hooked in our black to our line. You can see the L there, and we've hooked up our white to the neutral, and then we've hooked up the ground to this ground here. This inverter particularly doesn't have a ground for the it doesn't have a ground here. It has it down there for some reason, and then the AC in does have a ground. So we're going to take this plug and plug it in here. You say, will this ever get hot on the end? Meaning, will this electrocute you? No, because this is designed to be it's not designed to be hot. This is designed to take the input. So you'll plug a female end into this, and that female end will be hot, and then we'll provide that power. So we'll take this male end and we'll put it on the input appropriately. We'll hook the black to the line, we'll hook the white to the neutral, we'll hook the green to the ground. And so this is going to be an overview, a pretty in-depth overview. So if some of this is a little basic for you, just bear with me. I'm going to try to go over everything for those that this might not be basic for. So in this these wires here, these will be our battery cabling, and so this would be the minimum size I would even recommend for this 24-volt inverter, since it's a 3 kilowatt inverter. And you could do the math for how to calculate your wire size, but I would just recommend the bigger the better. Obviously it can get to the point where it's too big and a little too obnoxious, but for sake of doing this, we're gonna just simply show you how to do it. So on this inverter, we got to connect the wires in there, and then we got to put our screw onto there and screw that down. And we got to make sure our battery plus, we can see it's read it out right there, is red, and our battery minus is positive. That's the typical way that it is, because on a battery, the red is going to be plus and the black is going to be minus. And this is a custom built battery, but if you have a lithium battery or something else like that, it'll be labeled appropriately. So this is a 24-volt battery that we are using, and so we're going to go ahead and hook this one in, screw this one in, and then we are going to hook our solar lines into our solar, and this will let us plug our solar panels right into these lines here. And so we're going to go ahead and do that and come right back. All right, you can see we got our battery lines hooked in. So they are good to go. We technically could plug this in to our battery and fire it up, but we're gonna go to the solar lines. And so for our solar lines, how do we know which is positive and minus on this one? Well, we look on the inverter, and positive is over here and minus is over here. It also will tell us on our instruction manual which is which, positive and minus. And what does that mean with these? So the reason I like to hook these in is because it lets you just use normal solar wiring and just plug them into these, and it also gives you a way to disconnect the solar if you need to, if you don't want to wire in a switch on your solar. So how do we know which of these is which and how it's going to end up coming out of the panel? Well, if we look on the plug, you'll see right there is a positive. So do you think we put this one into the positive? No, we don't put this one into the positive. This one is labeled positive because typically out of a solar panel, this one is positive when it comes out of the solar panel. So what do we need to receive this one? We need this one. So to receive a positive out of a panel, which is what we're going to be doing here, we need this one. So just think of it this way. If you want to, an easy way to think of it is when you're plugging it into the inverter, do the opposite of what it says on the plug here. That's an easy way to think about it. So we're going to plug these in here, and so this one will obviously go into the positive, and we will tighten this down good and tight. Make it good and tight with these chintzy little things. And then we'll go in here with the other one. And this one we will go into the negative. Get it down there good and tight. All right, so that should be appropriate. Now we can plug one solar panel into this and it should work as long as the voltage is high enough on the solar array, and we will go over that in a minute and how to plan and configure your solar panels. So for now, what we're going to do is we're going to plug this one in, and then we will plug these into the battery. So I'm going to go ahead and hook these in here, shove this up there and hook these in. We'll be back. Okay, so we got this wired in, and now we're going to hook the battery to the inverter, and the inverter should turn on. And so this part, anytime you're hooking up an inverter, you can be aware that when you hook up an inverter, you see those capacitors in there, those brown things. Those things like to fill really fast with power. So anytime you hook up an inverter, it's going to like to do that. And it'll get you every time. So we're going to hook this up and then flip the switch on for the inverter and turn it on. Okay, so we got it all hooked up to the batteries, and the batteries is all you need. We can turn it on as it boots up. And it's now inverting, so we should have power on here. And we'll test that out, but we're also going to take an extension cord and plug in to here to test out the generator input. We're going to show you how that works and how that charges the battery, and show you what the readout is here. You can see our battery is discharging at about an amp. 30 watts is the idle consumption of this inverter. Not amazing, but also pretty decent for the size of an inverter it is. All right, we got our laptop ready to charge and got something benchmarking on it. And you'll see as soon as we plug in our laptop, we will get more consumption out of the inverter. So that's the usage of our laptop, kind of spiking around. Seems to go up every time our benchmark kind of spikes up there in usage, but that's where we're at. And we're going to put in a extension cord and test out the charging capabilities of this thing so you can see how that works. And then once we have some daylight, we'll plug in a solar panel to this and show you how this works. All right, so we're going to plug this in. Should switch over. It is now running the load. This is kind of what that means. Running it off of the AC. Now it's going to ramp up and start charging the batteries. And it'll probably slowly ramp up and do that. I think these inverters have a pretty fast charging capabilities. Oh yeah, 40 amps. So this makes for running generators far more efficient than just running a generator to run 100 watts or so or charge your phone. So that's how that works. All right, I'm gonna warn you, this is the part that tends to get over people's heads. And I wanna try to explain it as simple as I can. When building your solar array for your system, you have to understand and consider the limitations of your system. So the easiest way to understand the limitations of your system is to look on your label. Right here, you can see our PV. Our PV input understands photovoltaic input. We can understand its limitations by looking at the wattage. Hypothetically, hypothetically, this can handle 1,600 watts of solar. But realistically, it's pretty hard to get there exactly. And there's a lot of different reasons why. Because the limitation is in the amperage and voltage. You have to consider both. And so if we had 40 amps at 30 volts, then we would not have 1,600 watts. So voltage, wattage is volts times amps. You have to consider them both. Equals watts. So right here we have 10 volt. This is just an example. This isn't actually going to be the voltage of our solar panels. But if we had a 10 volt panel and it was a 1 amp panel, then we would multiply these two. 10 times 1 is what? We would have 10 watt panel. Okay? So, the same with this one. Multiply these two, we get a 10 watt panel. 10 watt panel, right? And so we got the same up here. And so I'm going to try to help you understand the difference between a series configuration for solar panels and a parallel configuration and what that means with the limitations of your system. So these systems are a little better, and in my opinion, they're a little easier to wire your panels in because you tend to not have to parallel them all. Paralleling panels is quite tricky, and you end up needing extra plugs and stuff to parallel panels. But hooking some in series together is a lot easier. And so this is a series connection, and I'll write it right here. This is a series connection because we have the panels hooked in series together, right? Both of these are considered basically the same panel because we have one positive and one negative coming out of both panels. Whereas a parallel connection, which we'll write this here, excuse my spelling, we have a negative and a positive and a negative and a positive coming out of the panel. And then of course we bring them together and we tie them together, so we have one negative and positive, but we have to tie those together. And it's not as easy to do because we have plugs like this on the end of each one, and they don't plug together well when they're not series connected together. So what's the difference between this and this? When we series them together, we are multiplying the voltage. So the amperage stays the same, but we are multiplying the voltage. So now we take these two panels and we end up with an output of, I'm gonna write it with this, 20 volts and 1 amp. Okay? So when we multiply those two together, 20 times 1 is 20. We got it. So when we add these two together, we have a 10 watt panel and a 10 watt panel, it's 20 watts. So wattage doesn't change when we do this. Wattage is the same. But when we want to try to get to the limits of this, we have to do the math on our panels, look at what the voltage of our panels is and the amperage of our panels is, to try and get as close as we can to the wattage limits of our system to get the most out of our system. So a parallel configuration takes a 10 volt panel and a 10 volt panel, and we take the negative and we run it over to the other negative and we hook them together. And then we take the positive and we run it over to the other positive and we hook it together. And so our output on this configuration ends up being 10 volts, but it's 2 amps. So what is 10 times 2? 20 watts. So that's what we end up with there. We end up with a 10 volt 2 amp, or we end up with a 20 volt 1 amp. So realistically, most used panels you'll probably get your hands on are around a 36 volt configuration. So those panels you would need to do the math on them. You'd look at the voltage and you'd look at the amperage and you try to get as close as you can to this here. You want to get the voltage as high as you can. Really, honestly, that's the goal. So what do? We need to find this right here, our 85. Now our max open circuit voltage is 100 volts, but that doesn't matter to us. We want to see what the max MPPT, which is the charge controller in here, the charge controller that tracks the maximum power point tracking on the solar panel. So it tracks the solar panel and it only goes up to 85 volts. So we want to make sure 2 panels in series of 36. So if we have 36, and we series them together, we will end up, when we add them together, we end up with 72, 76 volts. So since 76 volts is under the maximum MPPT voltage range, we would be fine with 2 panels in series together on a 36 volt panel. If we add another panel, we'll well exceed the 80 volt range, the 85 volt range, so we won't go into another panel in series. But what we can do, since we're only probably at about 8 amps with our solar panel, each solar panel is 8 amps, so we series them. So 36 and 36, we got 72 volts, and the amperage stayed the same. So we have 8 amps, and obviously you can see here our amperage limit on this charge controller is 60 amps. Sorry, it's actually 40 amps. So we can parallel a couple sets of 2. So now we have 2 series together, and then we take each set of 2, and then we do this to it. We take the positives and the negatives out of those sets, and we run the sets together so that we can increase the amperage. And the higher we get the amperage, the more wattage we end up giving into here. And so this is where it can get confusing for many people. And the 24 volt version of these, you end up having to series and parallel to get to the amperage limits on these, but the 48 volt versions do pretty good. You can series quite a few panels together, and then you typically end up having enough wattage that you need. You can go up to 400 volts on the 48 volt version of these, which is really nice, and some of the newer ones are getting the other models are starting to go up higher voltage too, which is extremely nice to be able to do. You don't have to parallel and series a bunch of panels. And so that's in a nutshell how to hook everything up, and then how to do the math for your solar panels. I know this is a long video, but if you have any questions, feel free to comment.